Welcome everyone to our September coffee chat about data conservation and with our host Jessica DeYoung from Naples Botanical Garden. I am Shanna T. Jones, social media and community outreach assistant for IrisBG. With us today is Laura Knudsen Murray, our GIS coordinator and community outreach assistant, Oyvind Rustin, the founder and CEO of IrisBG, and Maury Wiston, our Director of Strategy and Product Manager. The recording, presentation, and other material will be made available in our Knowledge Library. All our previous coffee chats can be found there in the category Articles and Presentations. You can also follow the topic IrisBG Coffee Chats and be notified via email every time something is published. The idea with these sessions is to offer a space where you can connect with your peers and have a chat about IrisBG and any issues pertaining to plant collections and record keeping. We don't have a fixed format on these sessions, so please get in touch with me or Laura if you would like to present a challenge or talk on a particular topic. It can be big or small. We want to hear it all. Hopefully you can make some new connections here today and we might just become a little wiser. Our next coffee chat will be October the 10th. So for this next coffee chat, we would like to host a presentation on end of the year reporting strategies that plant recorders can share with their organizations and shareholders. And so if you have, we actually have a question for you all. Does anyone have any tips you'd like to share for that coffee chat, especially when it comes to visualizing data for reports? Feel free to share any other challenges that you would like to discuss in the future as well. We do want to let you know that later this month, September 20th, Oyvind and Maury will be attending Plant Network's Plant Records meeting. This is at Sheffield Botanical Gardens in the UK. So if you see them, please say hello. There is a QR code if you want to take advantage of that to get more information. This is our map overview of all of the institutions represented here today. We're very happy to see some regions that we don't normally see in Central America, Mexico. To further learn a bit more about who's here today, we do have a poll that Laura will launch.
Thank you, everyone. I think we have everyone who's answered. You can just share it real fast. 41% intermediate, 32% novice, 23% advanced, and a few just trying out the trial. Thank you, everyone.
So presenting, I'm sure many of you know, presenting today on using IrisBG as a tool for data-driven conservation is Jessica DeYoung, conservation horticulturist at Naples Botanical Garden in Florida. She is a native Floridian, avid hiker, and a graduate of Florida Gulf Coast University. Jessica's passion and enthusiasm for conservation is evident within seconds of hearing her speak, and we are really, really thrilled to have her with us today. So without further ado, we welcome Jessica DeYoung to take the mic.
Thank you. Welcome, everyone. Thank you for attending today. I hope this talk gives you a lot of food for thought for conservation and also for botanical data mapping software. So to start, I wanted to talk the bulk of today about ecosystem conservation driven by data. All right, so just a quick overview of Naples Botanical Garden if you aren't familiar or heard of us before. We're 170 acres in Naples, Florida. We focus on plants of the subtropical and tropical longitudes around the world. And we are still relatively young for a garden. We're 14 years old, and our conservation department itself is only 5 years old. So in a way, we're just getting started. And I would like to take a moment to speak on our scope of work. There are varying levels of involvement a data-driven conservation plan can encompass, and it's unique to each garden what degree to take. I can provide some examples on how our work has been divided by scope, which will factor into the conservation plan later on. Locally, we have 90 acres of preserved land on site here at the garden. This preserve area will be used as an applied example of our data-driven conservation. We also work with our county, state parks, local nonprofits, and universities, as I'm sure each of your gardens have their hands in to some extent. So regionally, Southwest Florida is part of the Caribbean. And in this map here, you can just see the tail end of Florida and the Caribbean islands just beyond. With our subtropical climate to unite us, Naples Botanical Garden leads the coordination of the Caribbean and Central American Botanical Gardens network. So here's a great example of a little broader of a scope. On a national level, we are part of the American Public Gardens Association, APGA, which integrates us with the gardens across North America. We are also part of the Center for Plant Conservation, the CPC, which is spearheaded in California. This is a great resource for scientific standards of practice in conservation, and if you're not yet familiar with them, I encourage you to check them out. It's always great to see what gardens have collaboratively agreed on in their work and are willing to share for a greater impact. And finally, on a global level, we are part of the Botanical Gardens Conservation International, or BGCI. This organization has a major contribution in how we've steered our conservation efforts, which I will go into shortly. Before that, I wanted to take a moment and address that each garden has their own missions and goals. The data-driven conservation presented in this coffee chat aligns with a global strategy. So even if you only wanted to commit to a local or maybe just a regional impact, you are still contributing on a global level. Which leads us to finally talk about this global alignment I've been gearing towards. The Global Strategy for Plant Conservation, or GSPC, is a guiding framework to save the world's plant species. Its main goal is to halt the continuing loss of plant diversity. There are 16 targets and 5 goals, which probably sounds like a bunch of gibberish, but just know that within the strategy, these targets and goals conserve plant diversity on local, regional, national, and global scales. So we're seeing a recurring theme here. Now, if you refer to the picture on the left depicting the cover of the strategy, you can see the dates 2011 through 2020. They've just launched a new biodiversity standard only a few weeks ago, so it was much too close for me to incorporate it into this presentation. But for now, just keep in mind that these strategies are designed broad and overarching to still apply today. So there's going to be 2 parts to my presentation. The first half of my presentation will be steered by GSPC Target 8, Goal 6, which is to improve the status of biodiversity by safeguarding ecosystems, species, and genetic diversity. And that's a whole lot of words to remember, so I've just tucked that down here in a little byline to refer to. Historically, botanical gardens prioritize single taxonomic families or single plant species, but the conservation of today has a global shift to an ecosystem focus. Saving rare plants that are closer to extinction are high priorities, but collection efforts can be in vain unless the habitat is still functioning where it grows, which is nice to have a rare plant in your collection that's declining or functionally extinct in the wild. But the idea of conservation is to provide support for the plants where they naturally exist. So take the many-flowered grass pink, for example. This is a globally imperiled ground orchid, which is endemic to the southeastern United States. With our research and efforts to learn more about the species, we discovered that this plant has evolved alongside a natural disturbance of wildflowers. It will not bloom, and consequently, it will not go to seed unless a fire occurs. So before we can even obtain a sample to safeguard in our garden or in a seed bank, we work directly with land managers to help inform areas of interest for increased fire frequency. So this is one example of how restoration efforts must start at a habitat level. Oh, and then here's a little image of a prescribed fire taking place. So moving past the rare plants, we also need to be looking at the dominant plants in the ecosystem. Dominant plants are what make the habitat a habitat. Classifications are created by the species composition and the plants that make up the majority of the system. So without them, it is no longer a sustainable habitat, but instead a disturbed site. So in this background, we can observe Florida pine flatwoods habitat. And so the Florida slash pine here dominates the upper story, and the saw palmetto dominates the lower story. These are plants that are often overlooked for conservation, but introduced pests are already threatening their numbers, as can these unintentional introductions happen at any point, and the increasing threat of natural disasters are present more than ever. So finally, we do need to be looking at the common plants. Yes, they have an extended range and are less both-worthy in a botanical garden, but there are plants now listed as endangered that have once been common in the past. So the 2 plants here on the slide are wonderful examples of the ones common throughout the majority of Florida. So occurring in scrub habitat, which has the highest elevation, and consequently it was the first to be developed in our water-prone state, these plants are now referred to as common where found, meaning scrub habitat itself is a threatened ecosystem and rare, even though these plants are abundant within it. So now, here's a deep dive question to all of you, and it's just rhetorical, but give it some thought. Think to some of the well-known and native common plants near you. Is there research on how to propagate them? And do you know if they can be seed banked? These are the questions we need to be solving now before a plant is threatened in order to implement successful conservation while the species is still abundant. Proactive conservation, not reactive, can turn an unfortunate situation into a success story just by having a timeline for an actionable plan. And I realize this is a major undertaking, and it almost seems a little impossible to tackle looking at all the different plant levels of an ecosystem. However, the best way to maximize your success is to conduct opportunistic collections. Absolutely target your rare plants first, but most of the time, we don't even know where those rare plants are in the wild. Or maybe if individuals are mapped, we're constantly monitoring to determine when it flowers or when it fruits. So never waste a collection trip. While you're out there, collect other plants and fruit. You'll be surprised how quickly you can build progress. And so how do we do this? Well, we develop a target species analysis, which is an undertaking that starts with a step and not a leap. Consider what is within your reach. For us, we have a managed preserve on site. If you don't have this opportunity, consider a close by conservation land or a partner you're already collaborating with. And at ground zero, you must have a completed floristic inventory for the property you choose to conserve. You can't begin an analysis of your collection targets if you don't know what plants are on that site to begin with. And finally, consider what is important to you. Look back to that scale of local, regional, national, global, and build your consideration of size into the analysis from the start, which I'll touch on in a moment. So when we ran our analysis of the Naples Botanical Garden Smith Uplands Preserve, we processed 257 native plant species. Of this, 161 were considered conserved, and 96 species were considered underrepresented, and I'll define that definition in a moment. But for a quick visual, that's 37% of our native plants right under our nose that we still have a large job to do. Underrepresented plant species are broken down into a number of ex situ collections, or also known as the external institutions or organizations that contain the plant outside of the wild. Anything at 3 or less ex situ collections we considered at risk, since little knowledge and genetic representation of those plants are safeguarded. And for us, there was a staggering 15% of our plant composition that is not conserved anywhere outside of the wild globally. And how did we get these powerful numbers? BGCI has a tool called Plant Search, and it is open source to everyone. Just search your plant of interest and learn how many gardens have reported it in their collection. So keep in mind that this data is only as good as it is recent. So I encourage anyone who is a member of BGCI to update their records. If your garden's information is not included in BGCI's Plant Search and you want it to be, I can explain that in the second part of this presentation. All right, so now let's get into the nitty-gritty data part. When building your target collection analysis, here are the first set of criteria I recommend. You'll plug your floristic inventory into the first column, which for PowerPoint, I've only listed 3 plant names here, but in Excel, this will be a long trailing list. Add your ex situ collections, and then you really want to track whether there is legality tied up with the plant species, so you can consider the correct collection permissions to obtain. Then, is your plant endemic? The fact that a species is occurring only in one place in the entire world is a big deal and definitely worth tracking. And finally, can you get funding for your collection? Is there a grant or a donor where the species generates interest? So being realistic, this will move a target up the priority list if there is money backing the conservation efforts. And now we need to consider what is important to your garden and its mission by geographic scale. Conservation rankings can change depending on the scope you're looking at. For example, Thrinox radiata, or the thatch palm, is listed as least concerned by the IUCN, which looks at the global status of a singular species. At its northernmost range in South Florida, however, this plant is state endangered because there are only a few plants in this small population. So take into consideration a species conservation status by scale to make better decisions on what your garden's targets and capacity could be. All right, so we were never going to get out of a presentation representing data without seeing an Excel sheet at some point. But I do promise that I'm going to make this simple and painless to walk you through. If we were to build out a species analysis, it would start out just like this. You'd plug in that floristic inventory in the first column, and then you'd use Plant Search to determine the number of ex situ collections that house that plant. And then you'll want to dig deep with your team and decide what conservation rankings pertain to you. And remember that essential information such as legality. And then one other thing to consider here is also to add the flowering and the fruiting time, which is best to plug in while you're already doing research on those plants. So filling in all these columns looks intimidating, but really we all only have so much time and so much patience to sit in front of a computer. So only fill in the rest of the details for your plants that are underrepresented, which will generate an organized list like this. It's a wonderful reference tool, but again, it's not as easily interpreted at first glance. So what you'll want to do is group your plant species into easily digestible tiers to better understand your collection impact. So here we started with tier 1, which we named exceptional species. These are plants that are in 0 ex-situ collections and are endemic. From there, we moved to tier 2, which is exempt in ex-situ collections, because while they're still in 0 collections, now they have a wider range here in Southeast USA. But the overriding point here is to prioritize by the greatest threat of loss. And so I have created a template species analysis that is open to the public with highlighted fields containing comments that guide the process. You can access this with a QR code. In the interest of time, I am going to continue the presentation, but I will come back to the slide at the end for you all to grab that QR code if you're interested. All right, so now we're on to the second half of the presentation. This will be based on GSPC Target 16, Goal E, enhanced implementation through participatory planning, knowledge management, and capacity building. All right, so let's go into how to contribute your data using BGCI's plant search. Every living collection can make an important contribution to plant conservation, but in order to include your data, you do have to register as a garden editor, and that does require a membership. Remember that access to this database is free and open to the public if you simply wanted to see how well conserved a plant species has been reported. But for the data to be accurate, it's best to contribute each of your own institution's data where possible. When going into the plant search page on their website, there are several tabs on the left-hand corner. There are very simple and easy to interpret upload instructions tab that makes uploading information a breeze. So please keep in mind that there's a little note here at the top that says the website is currently frozen. It is getting revamped, so new submissions or updates are currently on hold. And again, that just so happens to coincide with my presentation. But when they do come back online, you all know what to do. So shifting gears here to talk about the core of how IrisBG plugs into all of this, you can include all of your collection information currently sitting in your database very easily with Plant Search. Using the report function circled here, you can use the pre-templated export BGCI report, which is under this miscellaneous tab. See if my cursor goes over here, you got your report function here. And then if you just click on miscellaneous, you've got your export BGCI report. So when pulling a report, you can filter your selections to choose what to submit or exclude. But note that the provenance tab is especially important. Plants that are safeguarded in a botanical garden that contain wild genetics contribute more to ecosystem resiliency in the long run, as they are more adapted to the wild and its common challenges than something that was raised in a garden or a nursery setting that are much well cared for. And so it really is a simple and a quick click to use IrisBG's reporting function to pull the data into an Excel file, which can be submitted to BGCI. And it will look a little something like this on the screen. Your already existing accessions may or may not include locality data already. If you aren't using this field when collecting from the wild, I greatly encourage it. This feeds into a bigger picture that I'll move on to into a moment. But for now, just know that you can control what data is or is not submitted. If you have sensitive plants where you do not want to submit coordinates, you can simply exclude the data. And at the same time, BGCI will not share the details of the data submitted other than to report the species' existence in an institution. There's also a request system that must be submitted through the website that safely vets this request directly to you and your institution. So it's again, fully to your discretion what you wish to share. And so here is that same extracted Excel report. I've just scrolled over a little more to the right because it's got quite a couple columns on it. And as you can see, it's a very painless undertaking to gather all of your data together and import thousands of accessions, as indicated here by the almost 10,000 that are listed. And then BGCI can then use this data for greater conservation need, assessing the incorporated status of the plant of interest based on its geographic range. So here we have a study of the Simina reticulata, the netted pawpaw. So the green dot here represents, oh, let me move my cursor over. But this green dot right here, and that I'm looking at, and this is representing an ex-situ institution. So spoiler alert, that's Naples Botanical Garden right there. It also shows a range to represent the wild sourcing where the material was collected. So this kind of area right here is just to say what has been included in this ex situ collection there. And to walk you through this, the blue in that background there is a potential distribution based on habitat models. And that dark purple represents observed occurrences that have been documented, meaning for this plant species, the habitat modeling in the blue does not contain, well, it does maintain the bulk of most of this plant species. You can see there's still a few outliers just outside of that blue. And the light purple is where it's estimated to occur if within 50 kilometers of a documented plant. So here we've got a documented plant, and then you can see the 50-kilometer range. So that's just what that is showing. But it's a very quick visual, and it's very easy to assess that the pawpaw is far from protected given its ex situ range. And it encourages where collections should continue to incorporate the best genetic representation. So contributing your data and assessing BGCI's vast network can help you hone in on areas needing collections. But once your collection takes place, there is a handful of research that can be conducted and tracked using IrisBG. At our garden, we develop propagation protocols, as I'm sure many other gardens are prone to doing. We can easily track our experiments using the Accession Items tab. So a quick note here is Accessions tab right there, and we're on Items. And so a quick note, this number, the item number here is Z, we use as a qualifier to say that something is in a nursery. So if it's A, B, C, or D, it's in a garden bed. For us, Z we know is nursery. And then we kind of continue this pattern down to say if there is an experiment that we're tracking, it's still in the nursery and it's experiment A, B, C, and so on. So from here, we track the plant's history over time. So we can see the steps taken in culturing and germination success. So this little outline I've got here, you can see that when the plant was first just planted as a seed to be grown out, you can see when we've changed that status to propagation success. And then at the end there, we then deaccession it. So we want to leave the history and the record in this profile, but on the nursery end of things, we don't want to have this many different experiments going on to track. It's quite a lot of items. So what we do is we then will lump all of these experiments into item Z, just to say, this is from this accession with this many plants. And if we wanted to interpret our experimental data, we can just refer back to here. So when selecting propagation culturing as a status, so just for reference, so this is our propagation culturing status right here, and it's a drop-down selection that you choose. So when you select that, it comes up with other fields, which are selected right here. So we can track the type of material that we're using. So we're using propagules. If you wanted to do cuttings and so on, you can switch that. What treatment was used, where it was planted, medium, even down to the type of container that you have. And then whenever we've finished all of our germination monitoring and we know the successes of our experiments, we can plug in the average time for germination that it took for this plant. And then in the failure box here, we report the germination rate. So I understand that, say, if you had 100% germination rate and reported in a failure box, it sounds a little weird, but you can always just interpret that as 0% failure. And then you have a comment box here that you can really use to whichever degree you would like, but we track the range of time that it took for the plant to grow. So the bulk of everything grew in 133 days, but our very first sprout was at day 75 and our very last sprout was at day 142, to give you a better idea of expectations. And additionally, we can upload documents to the taxa page, tying all of these accession items together in the experiment. So here we use Dynex Excelsa as an example, and using the reference tab here, we can add our documents to the file option. And so this is just something where if you scroll down a little, this would pop up. I couldn't fit it in the screenshot, so attached it right here. And then using this plus sign, you can just add your document that's external to tie everything together into the propagation profiles. So when you view the taxa information iris, we can simply pull up that attached file and you can see a synopsis of a propagation protocol. So here's a snapshot of our format here. I won't make you all read it, but just for a quick visual representation, I wanted to show how easy it is to merge internal garden databases, such as information living in Excel or a Word document, and align it with IrisBG. Okay, before you panic at this page, which again looks like a bunch of gibberish, I won't go into details at all, but I just wanted to share how our own internal and hard to read documents are easily referenced in IRIS. So this is the very next tab that was on the same document right here. So this is actually made an Excel sheet. And so this is the very next page of it. And this is the data on all of our experiments conducted within this taxa, which includes all the accession items that just contributes to the overall big picture to see what experiments were made. So this same document can also be attached directly to the accession reference tab. And what I mean by that is you can link, instead of the general Thrinax excelsa taxa page, you can link it to an individual accession here or over here, but we choose not to, just to eliminate redundancies, but that is an option depending on what you want to track. And then after collecting seeds from the wild, we also contribute to long-term seed banking and viability studies. So a seed bank is a curious classification because for the most part, the seeds are considered preserved when frozen and accepted as living once attempting to culture. So as such, we created an accession item type named seed bank here. This is seed banked and it's of the preserved kind, which is, again, it's just built into the drop-down selection. You can choose preserved or living, and you can access this through the definitions section, which is just to show you this port here. If I could just scroll down from that, because this is the screenshot, it would show up here in the definitions, and you would use accession item types. All right, and your item fields will be catered towards the information needed about a seed bank specimen. So your location names can only apply to an item if the status is seed banked, which minimizes errors. So what I mean by that is right here we have location name, and I've described the type of freezer and where it's at. If you have a garden bed in your formal gardens, that will not show up for the drop down for your locations name because it's applied to a living item type and not a preserved item type. So that's where it's just minimizing any potential errors. And the material fields here are especially important as we can describe specific scenarios. So our content fields mainly describes the item was seed banked, so right over here. And then we can say for preparation type, we actually, instead of saying that how the plant, or I'm sorry, how the seed was cleaned or what was undergone before it was seed banked, we pretty much always just clean the seeds and then we put them in and depulp them, whichever it needs to go through. So we don't have a special need to record that, but then we can use this instead to say, why are we seed banking it? So we do viability trials, and at the same time, we have long-term storage. So we use this as a drop down to say, why are we seed banking this? What is that for? You can say to what percentage of relative humidity you desiccated it to. Go specific into the storage container, and then if any medium was used with it as well. So now here's where that tricky dual status of seed bank comes into play. So when tracking plants in the seed bank, we use our preserved module for seed bank type. So here we've got seed bank, and that's where you get all those selections I just showed you. And then to get the propagation data, which is to classify the item as living when growing out, we now need to create a new item for the planting type. So as shown here. And so it's very easy to do because all you have to do is subtract from the number of specimens you've put into the seed bank and just add it to the new item that you're creating. So it's very straightforward. Another trick that we use that I'll just run through briefly is, again, the item numbers that we use to track this. So our SB here stands for a seed bank. And then again, our Z is our nursery value. So we can see that something was in the seed bank. And then whenever we pull it out to grow it, it turns into SBA, SBB. So we know it's a seed bank experiment. And then at the end of everything, we've got our propagation success. Then we deaccession it because we want to keep that history, but we can't track every single experiment we do in the nursery. It's too excessive. So we deaccession it and lump it all into this now nursery value. So it's nursery and was once seed banked is essentially what that says at a glance. So our living planting type item then displays the same information as our propagation protocols. So once you switched it to seed bank and moved it to planting, you get your propagation values back again, but you still retain some of the information that you have put in the seed bank tab. So using our content tab here, we can actually use this. We link it to our label making software. And that way, whenever we print out a label, it has a little note here to say that it was seed banked. If people aren't familiar with what our item letters mean with the ZSB. And that's also why it's kind of lumped together in one big word, just to squeeze it in there and make it fit. And in the comments box down here, you can also put any necessary information you want. For us, we'll say maybe the length of the viability test that this was tested at. All right, so we have run through a lot of information. Let me just summarize really quickly our main outcomes. We related back to a global framework to guide the why of our collections and to tie into that using a species analysis strategy, whether locally or of farther range, to contribute to conservation on a much broader scale. Our conservation safeguarding is enhanced when we focus on an ecosystem rather than individual plants, focusing on diversity and the likelihood of survival in the future. And many examples have accompanied the bulk of this undertaking, and hopefully breaking it down to you in a clear and concise manner. But with that, I want to thank you all for joining today and to listening to me ramble about data for a little bit of time. And now I believe we'll open this up for questions. But before that, I do want to just bring this QR code back into it in case anybody was interested in taking a look.
Thank you so much, Jessica. You're doing incredible work. And I really appreciate how you really presented so well the big picture, which is what we're all shooting for. And then you also did a really great job of the minute details and going over those and explaining the IrisBG function. So thank you so much.